Hi everyone, hope everyone's safe. We're going to try it this way for the first time, see how it goes. I already wrote up the notes and we'll just discuss them. Okay, so let's begin. This is chapter 3.7. We're going to talk about absolute max and absolute min. As you can see, we still have our relative min and our relative max. We have a theorem, the extreme value theorem. If f is continuous on a closed interval from a to b, then f must have an absolute maximum and an absolute minimum. So here I drove an example, and here you can see this goes from -2 to 3. And let's look first at interval, a closed interval from -2 to 0. That's from here to here. Okay? The absolute max is 1 at 0. So here's 0 right here, and it is 1. X is 0, and y is 1. And we have an absolute min that is -2 at point 2. So we have -2 is our absolute minimum, and it's at point -2. Okay, now we look next. We have an open interval on one side from 1 to 3. So the extreme value theorem would not apply here. What we do notice is there's no absolute max, because when we get to 1, we don't have a maximum because it's an open interval. All right? An absolute min is -1 at 3. That's 0.3 -1. Okay, so I'm going to go on to page 2 now and just put this up on the whiteboard and see how this works. Oops, that fell down. I do have a magnet. Oh, that works fine. All right. So, recall the relative maximum minimum occur at a critical number. Hence, to determine absolute extrema, we find all critical numbers in the interval and evaluate them in F as well as the endpoints. So here's an example. Determine the absolute maximum on the closed interval from -2 to 3. For f of x equals 2x cubed minus 3x squared minus 12x plus 5. We look at the derivative. F prime of x is 6x squared minus 6x minus 12. We set the derivative to 0, and then we solve to find our critical values. Notice both these numbers, 2 and -1, they fit in the interval from -2 to 3, the open interval. Now we go to test the endpoints and the critical numbers. So we start with the endpoint right here, -2. We take f of -2 and we find out that it's 1. And then we take f of -1, which is our critical number, and we find it's 12. And then we take f of 2, which is also our critical number, and find that it's -15. And then f of 3, which is our endpoint. Now from these, we check to see which is our smallest and our largest. As we can see, our smallest is -15 and our largest is 12. So we end by saying the absolute max is 12 at -1, and the absolute min is -15 at 2. Okay, let's go on to the next page. Let me take this off. Okay. Excuse me. Okay, there we go. Okay, so here we have determined the absolute max on -2 to 1 closed interval, where we have the function f of x equals x e to the 2x. We take the derivative of f prime x and we use the product rule. So we leave the first one, take the derivative of the second one, use the chain rule, plus the derivative of the first times the second one, and we end up and look for where it equals to 0. We notice e to the 2x cannot equal 0, so we solve for the next one, 2x plus 1. So x equals -1/2 is a critical number, and it fits in -2, 1. Okay, so from here we're going to test. We test our endpoint, once again, -2, with this function. So f of -2 is approximately -0.0367. And then we test our critical number, -1/2. F of -1/2 is approximately -0.1839. And f of 1 is approximately 7.3891. So then we notice which is the smallest, which is the largest. So the absolute max is 7.389 at 1, and the absolute min is -0.1839 at 1/2. Okay, let's go a little bit further. What if we don't have endpoints? What if we have an open interval? All right, so we're going to handle that differently. Here's an example. Determine absolute max min on -infinity to 0 for f of x equals x times e to the 2x. All right, so we have a theorem for this. And it says if f is continuous on an interval and there is only one critical number c on the interval, then if fc is a relative max, then it must be an absolute max. If f of c is a relative min, then it must be an absolute min. So here we're going to use this theorem, and we're going to apply it to this problem. The first thing we do is we find the critical number, which we did earlier up here. So we set f prime of x equal to 0, and we find the critical number to be x equals -1/2. Then the next thing is we notice that -1/2 does fit in the open interval, and there are no endpoints. So next we take the derivative of that critical number and find that it's -0.1839. All right. Now what we want to do is find f double prime x to evaluate f double prime -1/2 to find if f concaves up or if it concaves down. Okay, so let's do the next page. And we're on our last page, so we're almost done here. All right. So here we have the first derivative, and now we're going to do the second derivative. Notice here again we have the product rule. So we put down the first, take the derivative of the second, plus we bring the first, we take the derivative of the first, because we multiplied it by the 2 for the chain rule, and then times that by the first. Okay, so we go ahead and simplify, and we're right here, 4e to the 2x times 1 plus x. Now from here we're going to evaluate at f double prime x at our critical number by the previous theorem that we've done for this to see if it concaves up or down. So we input it and we see that it is greater than 0, therefore it concaves up. All right, therefore f has a relative min at x equals -1/2, and f of -1/2 is an absolute min. That's the theorem. Now, hence by the theorem that we're going to conclude, hence the absolute min is -1.1839 at -1/2. Okay, let's do our last problem here. Find the maximum profit for a shoe manufacturer, where we're given the cost function is 1500 plus 20x plus 2x 0.2x squared, and that's per week. And we're given the revenue function, Rx equals 90x per week. And as we note, the profit function is the revenue function minus the cost function. And when we do that, don't forget, when you have this negative here, you're going to need brackets because you don't want to forget that we're going to distribute that. So here it is where we've distributed the negative. And then, of course, we put the x squared in the front and work from there. Now, when we do that, we notice our profit function, hold on, this is falling down. Our profit function is a quadratic, and it's negative right here. So we can see that we're going to have a max, okay, because it's concaving down because of that negative sign. All right, so let's take the derivative. We take the derivative, set it to 0, and we find that where the max is where we have 175 pairs of shoes. So we input 175 into the profit function, and we end up with $4,625. So we can conclude the shoe manufacturer needs to sell 175 pairs of shoes to make a maximum profit of $4,625 per week. All right, I'm always going to post up these notes because I know it must have been hard to write these notes while I'm talking. So in the future, I will post the notes and you can look at the notes while I'm talking as well if that helps. I do recommend, though, since you are learning this, that you rewrite your own notes after this is over and you see my notes. It really helps to do your own notes. It's kind of like, once again, that I mentioned, if you want to be a pro basketball player, you don't watch someone else who already is a pro basketball player and expect to be as good, right? So if you do your own notes, you believe me, you'll learn a lot better that way. Okay, if you have any questions, go ahead and ask on the email. Thanks. Bye.